This video will present solutions to the VCE 2024 Mathematical Methods Written Examination 2, Section A, Questions 16 to 20. Question 16 provides us with some information about some function f of x and its derivative f'(x), specifically their values at x equals 4. Based on this, we need to determine the gradient of the tangent line, in other words, the value of dy and dx at x equals 4 if y equals the square root of f of x. If we express y as f of x to the power of a half, then dy and dx equals a half times f of x to the power of minus a half times f'(x) by application of the chain rule. We can use this expression for dy and dx to find its value at x equals 4 by substituting in the information we were given in the question about f of 4 and f'(4). This can be simplified to 3/2, which is answer D. Question 17 asks us to read some algorithmic code that will determine the roots of this cubic function. These roots can be found by setting the cubic equal to 0 and solving in ClassPad's main app. The roots alone, however, do not answer this question, as all the answers given contain the same 3 roots in different orders. So, the question is, in which order will this algorithm find the roots of f of x? The third line of code tells us that the value of c starts at f of 0, which in this case is 18. It then checks if c or negative c is a root of f of x. The 14th line tells us that the code then moves to c minus 1, which means it will then check 17 and negative 17, 16 and negative 16, and so on. As a result, the first root it will find is 3, and then negative 3, and then 2. And so the answer is D. Question 18 involves finding the value of x that maximizes the area of this trapezium. To find this maximum, first we'll need an expression for the trapezium's height in terms of x. This can be found via a quick application of Pythagoras' theorem. With that, we can enter into ClassPad's main app an expression for the area of the trapezium in terms of x, based on the area formula a half times the sum of the parallel sides times the height. Note, if you didn't recall the formula for the area of a trapezium, the shape could be reconfigured by joining together the 2 triangular areas, and then it can be considered a rectangle with a base of 2x. Either way, the area expression can be maximized using ClassPad's handy fmax command, which can be found in the interactive calculation menu. Whilst it makes sense to limit the calculation to positive values of x, in this case it doesn't make any difference to the output, which tells us that the area is maximized when x equals 5√2. Question 19 presents us with some information about a normally distributed random variable. This information can be represented diagrammatically. By symmetry, we can deduce that the mean of x is mu equals 14. Next, I'm going to find the value of sigma by setting up an equation involving an NCD calculation. I'm going to do this by calling up the NCD command from the Action menu for a change. Unlike the interactive menu, the Action menu does not give me the input wizard, it just gives me the command. As it is a very familiar command, I know that the inputs are lower, upper, sigma, mu, and so, based on the fact that the probability of x less than 10 is 0.2, I will enter negative infinity from the Math2 keyboard, 10, x, 14, where x is the standard deviation sigma. I'll then close the brackets, equate the command to the probability of 0.2 and solve. With sigma found, I'm going to modify that NCD command to find the probability of x less than 12. Dropping it into a new line, I need to change the upper bound to 12, delete the x, and drop in the value of sigma. This output tells me that the answer is C. Question 20 involves a periodic function f of x with a period of 2 and an average value from 0 to 2 of k. As the function is periodic, it will have the same average value from 2 to 4 and from 4 to 6, and therefore will have the same average value from 2 to 6. As such, the definite integral from 2 to 6 of f of x dx divided by 6 minus 2 will be equal to k. From that, we can deduce that the definite integral from 2 to 6 will be equal to 4k, which is answer C.